All right. So for this one, it says sketch the region corresponding to the statement z less than negative 2.6. Okay. So what's neat is you can click and drag the arrows, and you can also change it. You can change, do you want the right to the right of the value shaded to be shaded? Like, watch, I could change it and it goes to the right of the value, or I could say between two values, and then it would introduce a new value if we wanted to do it that way. So it's giving you a lot of choices, or you could say two regions. So if they say the value is less than 0.26, well, the first thing we need to do, I don't see two numbers to put. So I don't think it's two regions or between two values. I think it's either the right of the value or the left of the value. So we'll just say for right now, it's the left of the value, and then we'll talk about it more. Okay, so the first thing is we need to make this is the number we need to be at on the x list. So negative 2.6. So as we go to the left, we're getting bigger negative numbers. So it should be 6 spaces here. There we go, after -2. And then they said we want values less than, we want to find the probability that this normal random variable is less than -2.6. So we want to shade the values less than, and so numbers less than 2.6 are going to be to the left. So we do have the correct shading. You can barely see the shading, it's really small right now, but there is shading right here, and it is to the left of -2.6, and that's exactly what we would want. So that's what we want in this picture. Although don't get confused, because these are larger negative numbers, but larger negative numbers are actually smaller than small negative numbers. So that's why -3 is actually smaller than -2.6. So, all right, sketch the region corresponding to the statement that there's a value C between there's the probability that the probability that the random variable is between some C and -C is equal to 0.5. So we're going to be between two values. The random variable is between two values. So we definitely want this between two values. And this one, if we put it right here at 1 standard deviation, then actually this would be 68% of the data if you're within 1 standard deviation of the mean. So this being 68% of the data, that would not be correct. All right. So we don't know. The idea is that this is what the picture kind of looks like. It's not going to be exactly at 1 standard deviation, because we know that 68% of the data is between that, and we want 0.5. So it's probably going to be in a little bit, but we actually have to calculate. That's what we have to do. And we have to think about, this is 0.5. That blue region, we're not exactly sure. I mean, our numbers are 0.9 and 0.8 right here, but we don't know what this value has to be along the x-axis exactly yet. But all we know is the area between them has to be 0.50. So if the area in between these numbers is 0.50, that means the white tails on both sides have to add also to 0.50, because the area under this whole curve is one whole. So 1 minus 0.50 is 0.50. So that is symmetric about the mean, mean that this side is exactly the same looking as that side. So if we go out the same distance on both sides away from the mean, then so this, let me draw this in a little bit more or out. Okay, now it's 0.9 and 0.9. So it's the same distance from the mean on both sides. Then these areas, the white tails also have to be the same value, the same area. This white tail has the same area as this white tail, and those areas together equal 0.5. So 0.5, they have to be split, that 0.5 has to be split equally between the two tails. So it's 0.05 divided by 2, which is 0.25. That is the area here. And that's the area over here. All right, and then so what we need to do is that this value is unknown right now. I don't know if 0.9 was correct. So given an area under a curve to the left, we have to use the inverse norm formula. And we have to input the area under the curve to the left. So 0.25. And then this is the z variable. So we use 0 and 1 as my mean and standard deviation. So that's what I would put into my TI-84 if I were trying to find this answer right now. And remember, this area has to be the area and the curve to the left of the value we're trying to find. And then to find this right value, so that's how to find the left bound here. To find the right bound here, then so this is left bound. So the right bound, which is this right here, this value on the x-axis right there, this for the staying stops, that would be equal to the inverse norm what we know about this spot is that there's 0.25 to the right of it. So to do that, we would have to 1 minus 0.25 to find the area to the left, and then put the 0 and 1 instant, and then that would be how we found the right bound. So we can go ahead and do that using your TI-84 calculator. You can do that, and you have to just hit second bars to get that inverse norm function. However, you can't. I'm going to use the class calculator here. So I'm going to do this first one, 0.25 and 0 and 1. So the way we do this, do the inverse norm on the class calculator, is you just choose stats, distribution, do normal distribution. Because it's the z variable, I'm going to put the mean as 0 and the standard deviation as 1. And then instead of doing a CDF, I close the parenthesis, and then I go back to stats, I go back to distribution, and I go inverse CDF. And then I just put the area to the left, so 0.25. And it tells us that's negative 0.6745. So that is the answer that we want here for 0.64, right? 0.64. So that means that this bound needs to be at 0.6 or 0.64, which I would round to 0.6. And then actually, we know it's C and negative C. So it's just the value and then the opposite in sign of that same value. So I don't even have to do the other side right now. I already know if the answer for the other one side was 0.6, the answer for the other side must also be 0.6. But if we want to, we could just double check it by entering the same mean and standard deviation. So just do, instead of 1 minus 0.25, And then look, it's like I said, oh, it's 0.67. I believe 0.25, I'm sorry, so it'd be 0.7 right here. I rounded it wrong to 1 decimal place because we had to round it to 1 decimal place, so it'd be 0.7. So actually 0.7 and 0.7, and that would be our answer. There we go. So we could just double check it. It is, yep, there's 1, 2, 3 away from 10, so it is 0.7. There we go. And we can check our answers up here, and it is 1, 2, 3, 4. So 1, 2, 3, 4. Yep. So we're good. And it's to the left, and we did both of these correctly. All right. Please let me know if you guys have any questions, and have a great day. Bye.